I want to welcome you back to this lecture. Somewhere I'm busy taking you through mathematics, and so far we are looking at this section of mechanics, and we are particularly looking at the inclined plane. Definitely, we are looking at the horizontal force acting on a body, which is on a plane. And in our previous lectures, we have been developing these cases. So we now know at this level that for this, we always have a force mg. Then we always have a normal reaction R. So you can produce along here. So to have the vertical and the horizontal, you have, So these are the two forces acting. And at this level, you guys now know that this angle, if this is theta, definitely this one is always theta. Now we are looking at a horizontal force acting on the body. Apart from these two forces, which naturally act on the body, we can now have a force. The example can tell you that a horizontal force is actually acting on the body. So what shall we look at? How do we consider the horizontal force? So the horizontal force is always drawn in a way that is parallel to the horizontal plane. So you have your horizontal force, it acts along here in that direction. Okay, let me call it F. So that if this is theta, you can see that these two angles are alternate. So this one also be an angle theta. So such that we can now go ahead and produce this. When we produce this, what shall I have? I have always told you that you can start with the vertical and horizontal, such that now you can come and say that here I have my reaction R. Then down here I have my weight mg acting at an angle theta, and then I have a force F acting at an angle theta. Some people will go ahead and put it this side. That's also fine. It's very fine. It's very, very fine. So now, after doing this, definitely what can the student do? The student always is supposed to find the resultant force. So we come and look at resultant force. What is the resultant force going to be? So you can start with the reaction. That's going to be 0 R. Then you have your F. The F is going to be positive horizontally. That is F cos theta, and vertically is negative F sine theta. Why? Because if I bring this force here, it will point downwards. Actually, the best thing to see, if you are to look at this, when I continue with this force F, the force F is actually this side by virtue of its arrow. That means that when I resolve it horizontally, it will be pointing in this positive direction. And when I resolve it vertically, like its component Fx is in positive horizontal, and its component Fy is in negative vertical. That's why you have that. Good. So, but this is not necessary. You can see it from there. You can always get used to seeing it from that point. But this is where it comes from. Good. So now, after F, I can talk about the weight. So that's going to be plus, it's going to be negative mg sine theta, and here negative mg cos of theta. So you get this, if the body is in equilibrium, you get this and equate to 0, 0. All right. Now, if I'm saying if again, I'm using the word if the body is accelerating upwards, so it's good. You come and show the acceleration. And even in this diagram, you show that the body accelerates upwards in that manner. So that now when I am resolving, I'll be considering acceleration for sign conversion. So in that case, where I have acceleration, I will have my resultant force as equal to, start with the reaction, that's always 0 R. Then when I go to F. Now, like I told you earlier, if I continue with this F and you look at its components, the horizon of F will be in the direction of acceleration. So it will be positive. So this will be F cos theta, and vertical is negative, S minus F sin theta. Okay, plus this will not change, minus mg sin theta, and then minus mg cos of theta. I get this now. I don't equate to 0, 0. I equate to ma 0 because of the acceleration. And so this is what we have if we have a horizontal force acting on the body. So now I want us to look at some few examples. Let's look at example 1. Our example 1, they are actually telling us that we have a body of mass 5 kg placed on a plane inclined at 30 degrees, and saying that find a horizontal force. So the key word is the word horizontal force. And so when you sketch your plane, this will be 30 degrees like this head. You have a body. The body has a weight of 5g, and then it has a normal reaction R. So I do not want you to forget that the plane moves along here. Yep, so that this is an angle of 30 degrees also. And then we have a horizontal force. So say the horizontal force acts along here. So this is F. And then this angle will also be 30 degrees. So it will be good for you to reproduce this. To reproduce that, say that we have a vertical and a horizontal. The vertical, along the vertical we have R here. Then we have, here we have F at 30 degrees. Here we have mg of 5g at 30 degrees. That's what you have. So for part A, they want us to find F, so that this body is in equilibrium. So in my part A, I'll come and say that my resultant force, the resultant force F is equal to, start with reaction, that's going to be 0 R. When we come to the force, that force horizontally it's a positive, so you have F cos 30, and in vertical it's F minus F sin 30. So then you have the weight, so this could be plus, this is negative 5g sin 30 and negative 5g cos 30. This is equal to m to 0, 0, because part A is equilibrium. This is part A. So you can see that our interest is in resolving horizontally. So you can have, if you go horizontal, F cos 30 will be minus 5g sin 30 will be equal to 0. I've been saying we are considering horizontal forces. That means we are taking this, okay, and we are bringing it down here. So that means we're taking horizontal forces. So we have seen that, of course, the 0 becomes insignificant. So you have F cos and the minus 5g sin of 30 is equal to 0. Okay, so definitely if this one crosses the equal sign, it becomes a positive. And then that means that here I remain with F cos of 30, so I divide by cos 30 here and cos 30 here. So this one disappears. And we know that sin theta out of cos theta from trigonometry, that becomes a tan. That's why you have your F is equal to 5g tan of theta. Someone who will use the calculator in the best way will obtain the force F as 28.904. Don't forget to put your answers to 4 decimal places. Yeah, that gives us what we have in part A. That means if we apply this force of 28.2901, it is horizontal in this body, the body will be kept in equilibrium. And now we went on to the part B, where they're saying that we want to find that force applied on this body, a horizontal force applied on the body, said it accelerates upwards with 2 meters per second. And we said when we say the body is accelerating, it's so very much important to come and indicate that acceleration on the body. So it is accelerating upwards. That's why we indicate our acceleration upwards. You see it there. And I also indicate it on this sketch, on this reproduction that I've got. And I have it because they say the acceleration is 2. So that's why I make it 2 meters per second squared. And then definitely we come here, obtain the resultant force in this. So this is what we have as resultant force. But the difference will be that instead of equating to 0, 0, like the case was in equilibrium, here we equate to ma0. But our mass is 5 and our acceleration is 2. Okay, that's why I have 5, 2. And vertical, it's 0. So our interest is in horizontal, so we shall still come and take out the horizontal components. The 0 becomes insignificant, so we have 5 cos minus 5 g sine. Of course, 5 times 2 becomes a 10. Yeah, so this one can cross to become a plus. So at this side, we can remain with f and cos of 30. So you divide by cos of 30 and cos 30 here. So you remain with f is equal to this. Of which, if simplified, you'll get 39.8372. And still senior candidates maintain the 4 decimal places. So this will give you, of course, we give a bonus mark there, method mark, accuracy, method, and accuracy to give you your 5 marks in section A. I want to thank you for watching this video up to the end. Please, if you've liked the video, go ahead and like it. If you've not subscribed to our channel, please go ahead and subscribe to the channel. And then please go ahead and share this video with others so that we all benefit from this knowledge. The knowledge you have got, others also need to get. So be a loving neighbor. And then number 2, please, if you have any questions that you want me to answer, do not hesitate to put those questions in the comment sections. I'll be very glad to answer those questions. I wish you a blessed day.